Hello, everyone, and welcome to Ingmar Medical's webinar on using the test automation interface with the ASL 5000 breathing simulator. My name is Brian Lin. I am the product manager here at Ingmar Medical, and our presenter today will be Michael Bales, our director of engineering. We've tried to make today's presentation as concise as possible to be cognizant of your time. So we will try to limit the duration to about 30 minutes. The first 20 minutes will be the presentation, and we will leave at least 10 minutes at the end for questions and answers. We will be muting everyone's audio during the presentation, but please feel free to submit questions at any time using the chat panel through Zoom. We will answer as many of your questions as possible after the presentation. As always, a recording of the webinar will be made available to you via email. You can also access the recordings for any of our previous webinars under the training section of our website. We will be distributing a survey via email as well, so please let us know how we can provide you with the best possible webinar experiences going forward. So now I'd like to hand it over to Michael, our Director of Engineering.
Thank you, Brian. As Brian said, my name is Michael Bales, and I am the Director of Engineering at Ingmar Medical. Today, I will be discussing the Test Automation Interface, or TAI, for the ASL 5000 breathing simulator. This webinar is geared at providing some details on how to use the TAI and how it can be an effective tool for automation testing within any software environment. The topics for today's webinar include TAI background and how it can help improve time to market, setting up the TAI environment, some of the more useful commands, and we'll end with a short video example where we are controlling a ventilator and the ASL together in a single software environment. The native language for the ASL 5000 software is LabVIEW. Under typical conditions, a user works within the ASL 5000 environment. They use the GUI to create patient models, run simulations, and analyze the results. This adds a level of complexity if the goal is to use the ASL in a larger testing environment. With this in mind, we developed the TAI, which is designed to overcome this challenge by providing much of the control in the GUI through a software-agnostic application. All of the necessary information and instructions for establishing a TAI connection are encompassed in the TAI software specification document, which is currently at version 9. The specification document includes everything from structure of the application and how it communicates between the ASL lung, the ASL software, and the client application, details about sending and receiving data from the ASL 5000 in terms of the message structure, server information related to connections between the client application and the TAI server, the structure and meaning of the different command prompts, like input prompts versus response prompts, detailed description of each of the TAI 2-character commands. This includes the required and optional parameters of each command. In an effort to bring a correlation between the ASL software GUI and the TAI, we include a reference to where this control is used when working in the regular ASL 5000 GUI. For example, the ability to enable or disable a pause, or a passive patient running on the ASL, is visible on the Runtime Home tab in the ASL software. And of course, error flags for debug purposes. In all, the TAI performs most of the options available when using the typical ASL 5000 software. You can access the TAI specification document directly from our website to assure you have the most up-to-date version. So let's dig a little deeper into the structure. Here you can see the high-level design of the TAI application. The client or customer connects to the TAI server application via a telnet or similar protocol over port 6341. Once a connection is established, the client can connect to an instance of the ASL software and, through this connection, to a physical ASL lung. Please note the TAI does not connect directly to the lung. Instead, it opens either a visible or in the background instance of the ASL software, which then connects to the lung. This also means that the client application can connect to more than one ASL. To do this would require creating additional copies of the ASL software on the computer running the TAI and ASL software. The client application can then control the ASL and receive data directly from the ASL as either breath-by-breath parameters or through a variety of available waveforms. All in all, the TAI server application is at the center, responsible for sending and receiving data between the ASL 5000, the ASL software, and the client application. In order to establish communications to the TAI server, it requires a telnet-type connection using the local IP address or the IP address of the computer running the ASL software. Please know that the ASL software is always writing breath parameter information to port 6342 and waveform data to port 6343. These ports are always accessible regardless of whether you are using the TAI directly or using the ASL software. The data is also present on these ports whether waveforms are being saved or not. Let's take a look at the order of operations. Because this TAI is a standalone program, it is necessary to start the TAI executable before running the client application. When the TAI executable is started, you will typically see a message from the taskbar indicating that the TAI is listening on port 6341. When the connection between the TAI server and the client application is established, the TAI server provides the client with an input prompt that's equivalent to ASL 0000. As stated earlier, the prompt symbology is defined in the specification document. The client can then connect to the ASL simulator using the TAI commands. Once a simulation is complete, the client can close the software and exit the TAI with additional simple commands. In this case, EX exits the software and QT closes the TAI executable. So now let's look at some of the more important commands for setting up a simulation or a test. The OA, or Open ASL command, is the primary command to connect the client application to a physical ASL, or in some cases a software-only version if performing some preliminary testing. With this command, the user defines whether they are connecting via Ethernet, serial, or in this demo software-only mode. The user also defines whether they want the ASL software GUI to be visible or hidden. The TC, or tell condition command, is basically used to provide all the version information from the TAI down to the firmware in the ASL. It also provides information about simulation time and what patient model is currently running, just to name a few. The SF, or script file command, is used to load a .sct file. For those already familiar with the ASL software, the .sct or script files contain one or several VR3 or patient model files. The SF command typically loads the initial patient model for the ensuing simulation. The RS, or run simulation command, is used to name the output file for the simulation, determine whether to overwrite an existing output file, and to define whether or not to save the waveforms. Please note that saving waveforms can result in quite a large output data file set. Let's look at some of the commands based on manipulating the patient model as well as receiving output data from the ASL. One of the most useful commands is the IC, or interactive control command, along with the IM, or interactive mode command. The IM command moves the simulation into the, quote, interactive mode, unquote, and provides interactive control to the simulation or to the test. Using the IC command, the user can set new patient values like inspiratory resistance, breath rate, effort, etc. At the same time, by using the question mark within this command, the user is informed about any of the patient model characteristics. For instance, what is the current amplitude of the patient's muscle pressure, or what is my current value of my expiratory resistance? The BP, or breath parameter command, gives the client access to more than 100 breath parameters on a breath-by-breath basis. These parameters range from timing to pressure, flow, and volume to work of breathing parameters. The BP command can provide data on the last completed breath or in a specified breath within the simulation. For example, the client application may request breath every 10th breath, and this can be programmatically created through the BP command. The BW, or breath waveform command, outputs a single breath waveform that is either in a raw data format, meaning directly from the ASL 5000 lung, or in a processed format, meaning it has been processed by the ASL software. The client can also request the waveforms to be in various gas conditions like BTPS or ATPD, depending on their needs. Putting this all together, we've developed a simplified automated testing example. The goal is to completely drive the ASL ventilator testing through a standalone software application. The application is built in Visual Studio environment using C# programming language. In the example, we've created 3 simple tests that provide some idea of how the TAI can be embedded into the development or testing process. The first 2 tests are simply comparing the ASL's output with that of the ventilator's output. Test 1 runs 5 breaths in volume control mode, then produces a waveform. Test 2 runs 5 breaths in pressure control mode, then produces a waveform. And the third test is geared at triggering and validating alarms from the ventilator. Here, we use the interactive control option to increase resistance during the simulation to force the ventilator to alarm. Our goal is to trigger the low tidal volume alarm by reducing flow to the vent by increasing the resistance over time. Here are some code snippets showing the TAI command in use. As stated in the previous slide, we use the Visual Studio environment with the C# language. The design is made with WPF, MVVM, WinForms, and a third-party toolkit for the controls and waveform charts. Here is an example of how we invoke the BP command. We created the webinar breath parameters class, where we're calling 4 of the 100 plus parameters: tidal volume, peak pressure, breath rate, and PEEP. And you can see the TAI command and parameters in the orange script. Here's another example of how we invoke the BW command, or the breath waveform command. We created the ASL breath waveform class, and here we are parsing the output from this command to plot it inside of our GUI. Here's the example application we built for the webinar. It lasts about 3 minutes. In that time, I'll be pointing out some of the features. After the video completes, we will move to the questions and answers. On the left side of the screen is where we are constantly monitoring the application for any errors and recording everything for logging purposes. The right side of the screen captures outputs in a more elegant manner. As the test begins, you can see some of the TAI commands being invoked. SF is used to load our initial file, which is a passive patient. The TC command to capture versioning details. The BP command, which will pass data to the GUI for each breath. We also have ventilator commands being passed in terms of setting up the modes and initial conditions. On the right of the screen is our GUI, which is compartmentalized for easier feedback. On the bottom left, we have indicators to know we are connected to the ASL lung and to the ventilator. Above this, we're displaying the version information about our software, TAI, and lung firmware, as well as the ventilator information. This comes from the TC or tell condition command. We've chosen to plot the pressure, volume, and flow after each test completes in the chart area. At the top of the GUI, we have LEDs to monitor ventilator alarms. Below the alarms are data outputs from the vent, volume, PEEP, and PIP, and from the ASL, rate, breath number in the simulation, and the set resistance value, which is used in our third test. Finally, we can see the ASL and ventilator outputs next to our alarms. As I've been explaining this, we've completed 2 tests that could be based on comparing tidal volumes or peak pressures for 2 different modes: volume control in test 1 and pressure control in test 2. In the third test, we wanted to verify alarm limits. Here, as the simulation runs, you can see the IC command being invoked. Our volume limit for this test is 300 milliliters. As we increase the resistance in the lung, we expect a reduction in flow and thus a reduction in volume. In the log screen, the initial resistance was set to 6 centimeters of water per liter per second, or a healthy patient. And as the simulation progresses, you can see the IC command increasing the resistance to 21 centimeters of water per liter per second. And as this change is invoked, we can notice that our volume drops below 300 milliliters, causing the low tidal volume alarm to become active. And our simulation will end with another waveform that depicts the patient's breath that triggered the original alarm. And that should be ending one moment here as we get to the high level. And we're done. And that's our simulation test.
All right, thank you very much, Michael. I hope everyone enjoyed that little demonstration of our test automation interface for the ASL 5000. And now we would like to open up the floor to the participants here and see what types of questions we have from the folks who are attending. So please feel free, if you haven't already, go ahead and add your questions to the chat panel within Zoom, and we'll be fielding those right now. Okay, our first question here is from Ted. Ted asks, can you clarify the raw option from the BW command?
Yes, so when I mentioned earlier, there's an option for raw data coming from the ASL directly, or process data, which would be coming through our software. The raw data means that we are getting direct encoder count, volume, pressure information from the ASL where it has not been manipulated or modified through our software. Because the ASL 5000 does not have a flow sensor, we need to process the volume information that comes through from the ASL in our software. And so the processed data that comes from a BW command will give you flow information, including pressure and volume, but the raw data will only give you pressure and volume information.
Okay, thank you, Michael. Our next question here is from Wendy. Wendy asks, does the test software have to be running on the same computer as the TAI?
So the test automation interface, the TAI itself, and the ASL 5000 software must be running on the same computer. However, because you can connect to the TAI either through localhost, with the 127.0.0.1 IP address, which would be running it right directly on that computer. But if the computer is on a network, you could connect to the TAI via that IP address. So the client application does not have to be running on the same computer, but the TAI executable and TAI and ASL software do need to be running on the same computer.
Our next question is from Stefan. And Stefan asks, can you explain how to connect more than one ASL 5000 at the same time?
Sure. So when you issue the OA command and complete a connection, you'll see a prompt that says ASL and either the serial number or a COM port. When you want to connect to a second and third and nth ASL, you would use what's called the SA command. And the SA command allows you to connect to an ASL separately and then determine which ASL you're driving. So the SA command is the two-letter command that allows you to do that.
It looks like we have a follow-up question here from Stefan. This one is asking, is there a way to send a command to all ASLs at once? Or does each ASL need to be commanded individually?
Right, so same command with the SA command. When you type SA, it asks for what the ID is. If you set the ID to a specific ASL, you will be commanding only that ASL. However, we have the option where you can set the SA command to 0000, I believe, and that will then control all the ASLs at the same time. So it will send, if you're running multiple verifications against devices and you want the ASLs to repeat the same way, this is how you would be able to run that.
So our next question here is an ASL required to develop test software, or can software-only mode be used?
So one of the things I mentioned during the webinar was that when you set in the OA command your ID, you have the capacity to connect via Ethernet to an ASL using the ASL serial number. You can connect to a serial communications via a COM port number, or if you type the word demo in the ID command, it loads the ASL software in the ASL demo mode. So you can do a bulk of your development work in that environment without a physical ASL connected before you do any preliminary or realistic testing with a physical lung.
We do have one more question, it looks like, here currently, and that is there any reason I wouldn't want to save waveform data when running a simulation?
Yeah, so waveform data obviously is very important, and as I mentioned, you do have the ports 63, 42, and 43 available that provide telnet-based waveform and breath data all the time. For purposes of reporting and having all the data available, sometimes long simulations can really create large data sets that are cumbersome and too big, like if you're doing a 90-hour run. Sometimes you may just be interested in letting your device or the device under test continue through a long simulation and not having so much care for what the waveforms are. You just want to continuously run the same breath over and over again. So in my opinion, it's best if you have a really long simulation to not save waveforms, but if you care about the waveform output, then I would recommend saving waveforms.
Okay, yes, thank you again, Michael. And it looks like at the moment that's all the questions we have. So I would like to thank you all for joining us here today. And I would like to reiterate that we will be sending an email to you soon with a recording of this webinar. So if you missed anything, or if you'd like to go back and view this again, you will be able to do that. And I would also like to urge you to respond to the survey that you'll receive because we will be taking your feedback very seriously as we continue to hold these webinars in the future. So thanks again from Ingmar Medical, and we'll see you next time.